Hello everyone, today we want to talk about prime factorization and its applications. Before learning about prime factorization, we first need to learn some basic knowledge. The first thing we need to know about are multiples and factors, which I believe everyone knows about. For example, 8, 16, 24, 32, 40. These are the first 5 multiples of 8. 1, 2, 4, 8. These are all the factors of 8. Factors meaning 8 can be divisible by all of these 4 numbers. Now we need to learn something called index notation. What is index notation? When we were kids and we need to calculate 5 plus 5 plus 5 plus 5, we could easily write it as 5 times 4. Then what about 5 times 5 times 5 times 5, multiplied by itself 4 times? We can simplify this as follows. We read this as 5 to the power of 4. Writing it this way, this is called index notation. And the part to the left, this is called its expanded form. With the example above, we can easily see that 5 to the power of 4 does not equal 5 times 4. Be extra careful when you are calculating. Let's talk about what we are going to teach today, which is prime factorization. What is it? If we take apart 55 into 5 times 11, this is its prime factorization. This is because we took it apart by 2 factors, and these 2 factors are prime numbers. And so we have finished prime factorization. Let's try another example. 70. We can split it into 7 times 10. However, this is not yet the full prime factorization, because 10 is not a prime number. It could still split into further factors. So we go for an extra step. We split 10 into 2 times 5. 70 equals 7 times 2 times 5. Now this is the complete prime factorization. I think you can all agree that prime factorization is actually pretty easy. But what's it for? Let's look at its applications. We have just finished prime factorization for these 2 numbers, and one of its uses is to find its HCF and LCM. Let us first arrange the factors of 70 in ascending order. 2 times 5 times 7. To find the HCF is to find the highest common factor. What is the largest factor that these 2 numbers share? Obviously, it is 5, so their highest common factor is 5. Then how do we find the LCM? LCM is the least common multiple. This time we do it in reverse. All the factors that appear, we need to take them. When we took apart these 2 numbers, the factors that we see are 2, 5, 7, and 11. Although 5 appeared 2 times, its highest index is only 1. Therefore, we won't take 2 5s. We would only take 1. We now calculate this equation. We find that the LCM is 770. Some of you may say, when I was young, I learned another method to calculate the HCF of 55 and 70. After doing short division, the number on the outside, that is the HCF. All these numbers in an L shape, if we multiply them together, we would still get 770. Isn't short division easier? Why do we need to still learn another method? It is because this short division is only applicable to 2 numbers. If we need to find the HCF and LCM of 3 numbers, there are many little rules that we need to remember. It's not as simple as just doing a short division. Therefore, a very good application of prime factorization is that no matter how many numbers you have, once you have done the factorization, you can always find the HCF and LCM. Let's try another example. 16 can be taken apart into 4 times 4. But 4 is not a prime number. Therefore, we need to split it into 2 times 2 times 2 times 2. In this long equation, we can simplify it into 2 to the power of 4. We can split 18 into 2 times 3 times 3. In the same way, we can simplify it using index notation and write it as 2 times 3 to the power of 2. Let's try another number. 30 can be split into 2 times 3 times 5. Now let's use prime factorization to help us find the HCF and LCM. As mentioned before, HCF, we need to find the highest common factor that all of these numbers have in common. A common factor that all three numbers have is 2, but the first one is 2 to the power of 4. The rest are 2 to the power of 1. Which do we get? We need to get something that they all have in common. They all have 1, 2. 2 to the power of 4 is too many. Therefore, we only get 1. 2 to the power of 1 is enough. In LCM, the least common multiple is the exact reverse. We get all kinds of factors and we take them with the highest power. We see the factor 2 and the highest power is 4, so we take it. We see the factor 3 and the largest power is 2, so we take 3 to the power of 2. Although 5 only appeared once, but for LCM, as long as it appears, then we take it. So we write it down. Sometimes in the exams, we are allowed to write our answers in this way. We call this the index notation. But if the question did not say use index notation, then we need to calculate the answer. This means the real answer is 720. To summarize, it's actually very easy to find the highest common factor. As long as you have done prime factorization, we take all the common factors and we take them with the smallest power. LCM is the exact reverse. Whatever factors appear, you take it, and you take it with the largest power. And that's how you find the answer. That's it for today. If you have any questions, ask your teachers. Bye-bye.